Hello students, I welcome all of you to the next session, that is the lecture 2 for the vector differential calculus. So in this session we are going to discuss about the divergence and curl, their properties along with the applications in the solved problems. So let us start. So in the previous video lecture, if you have not checked it out, so please check it for your clear understanding. So now let us start with the definition of the divergence. So suppose here we are having one vector point function. V vector is a function of x, y, z. It must be a differentiable vector point function, where the v vector point function is defined as v1 I cap, v2 j cap, and v3 k cap, where v1, v2, v3 are the components along I cap, j cap, and k cap, that is x, y, and z direction respectively. Now the divergence of the v vector is denoted by div of v vector, and it is defined as div of v vector equals to the vector differential operator delta dot product with v vector. So now the vector differential operator, first order vector differential operator, that already we have defined in the previous video lecture. So that is equals to what? That is I cap del del x plus j cap del del y plus k cap del del z. So this is the vector differential operator. Now it will be dot product with v1 I cap plus v2 j cap plus v3 k cap. So whenever the dot product will take part, so the formula for the divergence will come, and the formula is very simple, that is divergence of v equals to del v1 del x del v2 del y del v3 del z. So if you remember, in the previous video lecture I have given you the formula for the gradient, where gradient is the scalar point function, and after find out the gradient of phi, the phi is a scalar point function. So after finding the gradient of phi, it is becoming a vector point function, while here we are calculating divergence for a vector point function, but after finding the divergence it is becoming a scalar quantity. So let us try to understand what is the physical meaning of a divergence. So basically, if we consider a pipe where the flow is coming from this side, left hand side, and flow is going from the outside, so this is the inflow and this is the outflow. So physically the divergence means that the divergence at a point for a given volume indicates the rate of outflow minus inflow, that is how much fluid is going outside of this portion and how much fluid is coming inside of this portion. So the difference between these two will be calculated, and that difference will represent the divergence at a specific point. So simply in a one line we can say the rate of a flux at a particular point is represented by the divergence at a particular point. Now if we calculate divergence and if sometime divergence can be 0, so if divergence is coming equals to 0 for the vector point function v, then this vector point function is said to be solenoidal. So for a vector point function, whenever divergence is 0, it is said to be a solenoidal vector point function. Now we come to the next concept, that is the curl of a vector point function. Suppose we are having a vector point function v vector xyz, which is a differentiable vector point function having the three components along x, y, and z directions respectively as v1 I cap, v2 j cap, and v3 k cap. Then the curl of this vector point function is denoted by curl of v, and which is defined as grad cross del cross v. So where del is the first order vector differential operator, we have to take the cross product with v vector. So how to obtain curl of v? So del cross v, so cross product will be done using the determinant concept. So I cap, j cap, k cap. Here first of all we have to write down the operator del del x, del del y, and del del z. Now the component of the v vector, that is v1, v2, and v3. Now if we just break the determinant, so you know the expansion of the determinant, so it can be done very easily. That is I cap. Now del del y del y will operate over v1 minus del z will operate over v2. Similarly, plus j cap if I consider, then del z will operate over v1 minus del x will operate over v3, and plus k cap del x operate over v2 minus del y operate over v1. So if we just summarize, then what we will get from the idea, that is the gradient of any scalar point function, it is denoted by this symbol, that is grad of phi. So this is simply the formula I cap del phi del x plus j cap del phi del y plus k cap del phi del z, which is nothing but a vector point function, though phi is a scalar quantity. Now divergence of a vector point function, this will be formularized as del v1 del x plus del v2 del y plus del v3 del z, where v is a vector point function but divergence becomes a scalar quantity, and curl of vector point function is represented by this formula, so which is nothing but again a vector point function. Now physical meaning of gradient and divergence already we have discussed, so let us try to understand the concept of the curl. When curl will appear, usually curl will appear whenever some body will rotate with respect to some axis, that is when the torque is coming, then we can measure the curl. So suppose one rigid body is there, this diagram, so this is the rigid body which is rotating about this axis, say this is the axis x. With respect to this rigid body is rotating with a constant angular velocity omega, and the tangent along the tangential direction, we have taken the velocity component as v vector. So if a rigid body is rotating about its own axis with a velocity field as v vector and the angular velocity as omega, then curl of v vector basically gets us the value 2 omega. So we can say that if a rigid body is moving about its axis, then the curl of its velocity vector is equals to twice the angular velocity. Okay, so this is the physical meaning of a curl. Now if curl of v vector is becoming 0 or null vector, then v vector is said to be irrotational. Okay, so if we see the divergence is becoming 0, it is said to be solenoidal. If curl equals to 0, it is said to be irrotational. Now let us come to some solution of the problem. So first problem says that we have to prove that this function f vector equals to 2x plus yz I cap, 4y plus xz j cap, minus 6z plus xy k cap is a solenoidal as well as irrotational. So if we have to prove it is a solenoidal, we have to find out the divergence of f vector. So divergence of f vector is nothing but del x of f1, del y of f2, del z of f3. What is f1, f2, f3? This f1, f2, f3 are the three components which is coming with I cap, j cap and k cap respectively. So del x f1 is 2x plus yz, del y f2 is 4y plus xz, and del z minus 6z plus xy. So if we just find out the partial derivatives, the result is coming after the calculation is equals to 0. So we can see that f vector is becoming a solenoidal vector point function. Now let us calculate the curl of the vector point function. So how to calculate curl? Just now we have discussed, that is curl of f is nothing but the del cross f vector. And how to calculate the cross product? By the determinant I cap, j cap, k cap, del x, del y, del z, and the three components we have written here. So just like the previous problem, the previous discussion, del y we operate over minus 6z plus xy, minus del z will operate over 4y plus xz. Similarly, minus j cap del x is operating over minus 6z plus xy, del z is operating over 2x plus yz, and del with respect to k cap, del x will operate over 4x plus xz, and del y we operate over 2x plus yz. So whenever we will do the partial derivative, all of you can see that I cap along with the coefficient is coming x minus x, j cap with y minus y, and k cap with z minus z. So definitely these all are getting cancelled out, and we are having the result as null vector. Therefore F is becoming an irrotational force field. So now, with this concept of this irrotational force field, we are having one most important part that we are going to discuss right now, that is the scalar point function, scalar potential along with the conservative force field concept. Though the conservative force field concept we are having in the line integral in the vector calculus, that we will discuss later, but right now we are going to discuss very briefly about these two concepts. So first of all, what is the meaning of the conservative force field? Suppose we are having a force field that is a F vector, which is a vector point function. Definitely this vector point function is said to be a conservative force field if the work done by this force field to move an object from the point A to B is independent of the path we are choosing. Suppose we are having a conservative force field region. Suppose this is a region which is a conservative force field region, and within this region, suppose we are having 2 points, say this is A and this is a point B. Now if this field is a conservative force field region, and in this force field if we want to move any part object from A to B through any path, suppose this path or this path, if I choose, or I choose this path, the work done is going to be independent of the path chosen. So for such kind of field is said to be conservative force field. So whenever a force field is conservative, always remember the curl of that field is going to be 0 only. So curl of F is going to be 0, so F will become irrotational. So for every conservative force field, the force field is becoming an irrotational force field. Now once the force field is irrotational, there is a concept of scalar potential will come. So if the force field is irrotational, then this F vector can be represented as a gradient of phi. That is, there exists a differentiable scalar point function phi such that this F vector can be represented as grad of phi. This phi is said to be the scalar point function or scalar potential for the F vector. Okay, so it will happen whenever the force field is a conservative, that is force field will become, that is F vector will become irrotational. Now we are going to discuss two very important questions for the exam. So let us try to understand. So first question says that show that the vector point function F vector equals to x square minus yz I cap plus y square minus xz j cap plus z square minus xy k cap. This is an irrotational. Along with that, we have to find out the scalar potential for this F vector. So usually we have to find out the curl F. So curl F is equals to del cross F vector, which is nothing but the determinant of I j k del x del y del z of three components, x square minus yz, y square minus xz, and z square minus xy. So previous question already we have discussed how to calculate this determinant. So after calculating this determinant, the result is coming as 0. Always remember, whenever the force field will be irrotational, then only we will be able to find out its scalar potential, otherwise not. So now we will consider that there exists a scalar point function phi such that F can be written as grad phi. Our task is to identify this scalar point function phi for which F vector and grad phi are becoming same. What is a grad phi? Grad phi equal to I cap del phi del x plus j cap del phi del y plus k cap del phi del z. Now since F vector is equals to I cap del phi del x plus j cap del phi del y plus k cap del phi del z, so we can compare F vector component with this right hand side terms. So comparing LHS and RHS, what we will get? the del phi del x value is going to be x square minus yz. Del phi del y component is going to be y square minus xz, and del phi del z component is going to be z square minus xy. So now how to find out this phi function? So let us try to understand it very carefully. So since here we have differentiated partially with respect to x, so that x square minus yz term is coming. So how to get back the phi function? If we integrate this function partially with respect to x, then only it is possible. So this first function we have to integrate partially with respect to x, just like partial derivative. Here we have to integrate partially with respect to x, treating other variables as constant. So y and z will be treated as a constant quantity. So integration of x square is x cube upon 3, and integration of yz equals to x into yz, because yz is constant. Now since we are doing the partial integration here, so one constant will come, constant of the integration, because it is indefinite integral. So the constant of integration will depending on the function of other two variables. So in this problem we are having y z also, so the arbitrary constant is basically going to be function of other two variables y and z. So we have written f1 of yz. Now similarly del phi del y, this is equals to y square minus xz. So we need to integrate this function partially with respect to y. So y squared integration is y cube upon 3 minus xz integration is minus xyz, plus since we are doing partial integration with respect to y, so the arbitrary constant is going to be function of x and z, which are not present in this integration. Okay, similarly del phi del z, that is equals to z square minus xy. So we have to partially integrate this. So phi is going to be z integration of z square minus xy with respect to dz. So here z cube by 3 will come. For xy it will come as minus xyz, plus since with respect to z we are doing the integration, so rest of the variables are x and y, so arbitrary constant is a function of x and y. Now our task is very simple. We have to identify any one of f1, f2 and f3 and substitute in any one of phi function, so that all the phi function is going to be same, because only one phi function we are having, for which we are differentiating with respect to x, we are getting this result, with respect to y we are getting this result, and with respect to z we are getting this result. So the phi function cannot be different for this for the question. Okay, so phi function will be unique. So how to get this unique phi function? We have to identify the values of this f1, f2 and f3. So what is our f1? So you can notice that f1 is a function of y and z. So here you do not search for yz function, you go for the rest of the two terms. Okay, so for rest of the two terms, let us find out which are the terms depending on y and z only. It will not involve any x related term. So here we are having y cube by 3, which is involving y term, and here z cube by 3, which involves z term. So what is our f1 of yz? That is y cube by 3 plus z cube by 3. Similarly, let us try to find out f2 function. f2 is a function of what? f2 is a function of x and z. So we have to search from the first and third. So in first one we are having function of x as x cube upon 3, and from the last we are having z cube upon 3. So f2 will become x cube by 3 plus z cube by 3. Similarly, we are having f3. So what is our f3? That is going to be function of x and y. We have to collect it from the first and second. That is equals to x cube by 3 divided plus y cube by 3. So any one of these f1, f2, f3 you put in any one of the phi function that you have obtained. Okay, so whenever you substitute this, you will see that this phi is going to be unique for all these three cases. So what is our final result? What is our phi function? X cube upon x cube by 3, y cube by 3 and z cube by 3 minus x, y, z. So this is the ultimate phi function. So let us make it more clear. I have given one more example for your understanding. So here directly we are going to find out the scalar potential. We are skipping the intermediate step for finding the irrotational vector field. So we have to find out the scalar potential for this field. F vector equals to x plus 2y plus 4z I cap plus 2x minus 3y minus z j cap 4x minus y plus 2z k cap. Okay, so let us consider phi xyz be the scalar potential for f vector. So f vector can be written as grad phi, that is equals to I cap del phi del x, j cap del phi del y, k cap del phi del z. So comparing what we get, the value of del phi del x, del phi del y and del phi del z. So the values are del phi del x equals to x plus 2y plus 4z, del phi del y equal to 2x minus 3y minus z, del phi del z equal to 4x minus y plus 2z. Similarly, we have to integrate the first one partially with respect to x, because it has done partially with respect to x differentiation. So integration we have to done partially with respect to x. So we get the result x square by 2 plus 2xy plus 4xz plus function of yz. Okay, similarly for the second one we have to integrate partially with respect to y. So after partial integration with respect to y, what we get 2xy minus 3 by 2 I square minus yz plus function of xz. And lastly what we have to do, we have to integrate partially with respect to z. So we get 4xz minus yz plus z square, because 2z square by 2 get cancelled out, it will come z square. So it will be function of x and y. So let us try to find out all these three functions, f1 of yz, f2 of xz and f3 of xy. So how to calculate this? What I have told you, f1 of yz you have to find out from second and third integration result. So you have to identify those terms which are involving only y and z related term. So you can see here minus 3 by 2 I square minus yz, the terms depends on y and z. Also in last we are having plus z square. So what is the functional value of f1 of yz? This is going to be minus 3 by 2 y square minus yz plus z square. Similarly, if you look at for f2 of xz, then from which two integration you have to find out the value? From first and third. So f2 of xz, you identify the terms which are involving x and z only. So here it is x square upon 2 plus 4xz along with this term z square again. So we are having f2 of xz as x square by 2 plus 4xz plus z square. Similarly, we can get the value of f3. Now after getting the value of f1, f2, f3, you substitute any one of the value in any one of this phi function. Either you can put f1 or you can put f2 or you can put f3, so that you will get the unique phi function. So ultimately we are getting the result as our phi function is going to be x square by 2 minus 3 by 2 y square plus z square plus 2xy minus yz plus 4xz. So with this video lecture is going to end. Next video lecture I am going to introduce the three most important formulas: Green's theorem, Stokes theorem and Gauss divergence theorem. Thank you all.